Today I'll be showing you how to use the shell method in order to find a volume of solid of revolution. So in Calculus 1 we learned that the area under the curve is a definite integral of f of x, and in Calculus 2 we extend our knowledge about the applications of definite integrals to volumes of solids of revolution. One of these techniques to calculate these volumes of revolution is the shell method, a representative of its shape. Instead of what we did in the disk and washer method, we'll be calculating it based on the volume formulas that we had learned in the past in geometry. The shell method, we are actually just adding up an infinite number of tiny shells or the walls of cylinders with integration from A to B to find the volume of a solid. So this is really just the natural way to compute volumes of solids. Essentially, we are unraveling a cylinder to reveal the walls of it, or our representative shell, and our length is really just our circumference of the circle, which equals 2 pi r times its height. When we multiply this area of the wall by its thickness, or dx, dy, as it approaches infinity, it's really just going to give us the volume of one shell. And by taking the definite integral of this volume of the wall of a cylinder, we actually get the volume of the solid of revolution. If we were revolving around the x-axis, our volume of solid of revolution formula would be V equals the definite integral of 2 pi y gy with respect to y from C to D. Our 2 pi y would actually equal our circumference, or 2 pi r, and our representative rectangle, or r, equals to y, or it's parallel to the x-axis. Our gy would equal our height, and our dy would be the thickness of each of the shells. And remember, our C and D is actually in terms of y instead of x in this case. As you can tell from the video, as our dy gets infinitely smaller, it becomes a better and better representation of our volume of revolution. If we're revolving around the y-axis, our volume of revolution will be V equals the definite integral of 2 pi x f of x with respect to x from A to B. Our 2 pi x would equal the circumference, our f of x would be our height, and our dx would be the thickness of each of our shells. And remember that the representative rectangle, or r, is always the x, or what's parallel to the y-axis. As our dx approaches infinity, it basically becomes a more and more accurate representation of our volume of revolution. I hope my video was helpful in your understanding of how to calculate the volume of a solid using the shell method. Thanks for watching.